Okay, so what we're going to be doing now is we're going to solve a stoichiometric equation using a BCA table. So what a BCA table is basically the amount of something you have before and the amount that is subtracted or changed or added and the result afterwards. So as we have here, you start out with, the given is you have produced 15 grams of iron. And what we have to do here is solve for how many grams you had to use of iron oxide and aluminum to get that amount. So what we do here is we have to start working backwards. So we zoom in here, you divide 15 grams of iron by the molar mass, and that equals 0.27 moles of iron. And so we have that right here with the 2 iron. And then we can also solve for the amount of moles used for aluminum oxide then, because if you divide that by 2, then you can convert it over to get 0.135 moles. And then for the actual part of the problem that we need to solve, you have to do the same exact thing. You have to divide and then multiply by the coefficient of the new number. So you would divide by 2 here, and then you multiply by 2 here. But in this sense, it's a 1-to-1 ratio, so you really don't have to do anything to it. So you would originally start out with 0.27 moles of aluminum, and you'd have to divide by 2 here, and you multiply by 1 here. So then you would start out with 0.135 moles of iron oxide. And then once we're done with those, finding the moles amount, you have to multiply each of those by each molar mass respectively. So then you would turn out to start out with 7.29 grams of aluminum, and if you multiply the molar mass of iron oxide by 0.135 moles, you would get 9.7 grams of iron oxide to start out.